Hello everyone. Today we're going to discuss how to use the SQL Query object in advanced mode within your EasyBuilder Pro project. Before we get started, you'll need to download MySQL Workbench and MySQL Server. And I'd like to note that our support team typically recommends MySQL Server version 5.7. However, if you prefer to install a later version, please make sure that Use Legacy Authentication is selected during installation. Throughout this tutorial, we'll be using some basic SQL script that will help you prepare to implement more advanced SQL concepts within your project. And with that said, if your application only requires basic SQL functions, such as the ability to add, create, delete, or update rows, or if you need your data sampling object within EasyBuilder Pro to sync data to a SQL database, please check the description for links to separate tutorials that cover these topics. Now that MySQL is installed on our PC, let's open MySQL Workbench and log into our local server. And once logged in, we'll begin by creating a schema and table. To create a schema, I'll select the Schema button in the top left corner. And our new schema window will open. Here we'll configure the name of our schema. Let's call this My Schema with no spaces. And I'll click Apply in the bottom right corner and follow the prompts on screen to apply our changes. In the bottom left corner, our new schema will be added to our list. So let's click the small arrow and expand the contents of our schema. And let's right-click on Table and select Create Table. Within our New Table menu, we'll name our table at the top. I'll call this My Table. And in the center, let's create a few data points. We'll need to create a primary key that auto-increments. We can call this No. And we'll select our Not Null checkbox as well. I'll also add an integer item called data and a character item that I'll call name. And I'll ensure that Not Null is checked for both of these items as well. Now we'll need to save our table's configuration by selecting the Apply button in the bottom right corner. And once again, we'll follow the prompts on screen to save our configuration. Now that we've finished with our SQL Workbench, let's open EasyBuilder Pro and create our SQL project. To do this, we'll need to select either a CMT or CMTX series HMI. Once our application loads, we'll close our system parameters and select the Data/History tab. In the top right corner, we'll click Database Server, and in the following menu, we'll select New, and then define our server's configuration. At the top, I'll ensure that the server type is set to MySQL. I'm going to keep Use IP selected and enter our local host IP, 127.0.0.1. This will allow EasyBuilder Pro to communicate with our local server while testing through simulation. I'll also leave my port at its default setting, 3306. And then configure our MySQL username and password. And the name of our schema. Let's select the TLS/SSL tab. And so during this demonstration, we won't be using TLS or SSL encryption, so we'll leave this option disabled within our settings. And within our status/control tab, you can see that our status register, which is enabled by default, can be used to monitor the connection between our HMI and SQL server. I'll leave this address set to LW0 and click OK to save our configuration. Now I'll exit our database server dialog and we'll select our SQL Query object. Once again, in the following dialog, I'll select New, and our query object's configuration will be displayed. In our last video, we used this menu to create a basic query object with 4 commands: create, read, update, and delete. Today, we're going to select Advanced Mode in the top right corner and write our own SQL commands. After selecting this button, we'll receive a prompt stating that this action cannot be undone for this particular query object. So we'll select Yes, and our Advanced Query menu will be displayed. At the top, I'll ensure that Remote is selected within our database drop-down list. And then we'll select our Command tab and review our configuration. At the top, we have our control address, which we'll use to submit commands. And you can see below that our query object actually allocates 68 words by default to allow us to monitor row selection, status, and error messages as well. And if your database is configured to return a custom error message, you can actually expand the word count by selecting Customize Length for Error Message. And because our database is currently using LW0 for its status register, I'll define our query object's control address to LW2. At the bottom, we can add, delete, copy, paste, or reconfigure the settings of a command within our list. And with that said, let's create our first command. To start, we'll select New on the bottom left. Now when creating a command, the command ID that you see here at the top will be used to trigger that command. In other words, to trigger this command, we'll need to write a value of 1 within our LW2 command register. Let's create a description for our command. I'll call this table: mytable/create. Because unlike our basic query object, our advanced query object can be used to interact with multiple tables inside a single schema. To write our create command, we'll use the following keywords: insert, into, mytable, and in parentheses, data, name. So now we have to define where this data will come from. And in order to do that, we'll need to define some arguments in the form of registers that we can pass into our statement. So let's select the Argument tab and define some registers. To do this, we'll select New on the bottom left, and our first argument will hold numeric data in our LW71 register, which we'll use for our data column. And we also need a second argument, which will hold string data. It will be addressed to LW72 with a length of 5 words. And we're going to use this for our name column. Notice that each argument has a number on the left side. This number will be important when writing this query. I'll switch back to our Query tab, and I'm going to introduce another keyword called values which is necessary to construct data within our table. The values keyword has parameters that we'll use to pass our arguments to the SQL database and into our table. In front of our keyword, and in parentheses, I'll type apostrophe, $, and in curly brackets, the number 1, which represents the first register in our list of arguments. I'll close this with a second apostrophe, and then type comma, and repeat this process for our second argument. We'll then ensure our parentheses are closed and end our statement with a semicolon. Semicolons are required at the end of each statement in MySQL. Now I'd like to note that I could add our primary key, called no, within our command, but because this is set to auto-increment, I found this unnecessary. Before we click OK and save our command, you may have noticed the Discard Result checkbox at the bottom of our query statement. This option is intertwined with our SQL Query View object and will allow us to send our command without displaying the result within our object. We'll select this during this example. Let's click OK, and our command is now displayed within our list. And we'll create a second command to read data from our database. Within my command's description, I'll call this table:/mytable/read, but you may call this what you like within your application. Now we're going to use the select keyword to read data from our database. To do this, we'll type select *from my table, and we'll end our statement with a semicolon. I'd like to note that when using the asterisk in front of select, each column within your table will be returned by this statement. If we want to be specific, we can define a specific column in front of our select statement, such as no, or define multiple columns using a comma in between column names, as in no, data. We can even rearrange our column names to reorganize our output. However, I'll leave my statement as is during this example, and unlike our last command, we'll leave discard result unchecked because we want to view the output of our result. And because we are returning the result of our query to the SQL database, we might want to define some output registers. So let's select the Output tab, and we'll add some output registers. To do this, we'll select New in the bottom left corner, and we'll address our register to LW70. This will be a 16-bit register that will hold the numeric data from our no column. Next, I'll create a second numeric output register. I'll address this to LW71, and we'll use this for our data column. And of course, our result will contain all 3 columns, meaning that we'll need a third register for string data with a length of 5 words. This will be addressed to LW72. With that finished, I'll click OK, and we'll exit out of our SQL menu so that we can place some objects on our work area. Let's start by creating our SQL Query Result View object. This object can be found within the Data/History tab just under our SQL Query object on the top right. Within our View Object settings, we can configure the SQL Query object that our View object will display. The look and appearance are also customizable, and we can even enable a filter to quickly search for specific data from our returned result. For now, I'll leave our configuration as is and place our object. Now we'll need to create some objects that correspond to our arguments and outputs. To begin, I'll select the Object tab and add a numeric object, which we'll address to LW70, and this will correspond to the No column of our SQL database. I'll copy this object and address this to LW71 for our Data column. And of course, we also need a 5-word ASCII object addressed to LW72. For this demonstration, I'll also make 2 set words as well to trigger our create and read commands. They will both be addressed to LW2, our command register. The first object will submit a value of 1, which will send the insert query to our SQL database. I'll give this object a label. And the second will submit a value of 2 to our command register, which will send our select query. With that finished, I'll select the Project tab and run an offline simulation. With our simulation running, you'll notice that I have my MySQL workbench open as well, so that we can monitor our data in real time. Let's go ahead and use our read command to view our data table. After executing our command, you'll notice that at the top, a description of our query is displayed. If within your application, a description of the query is unnecessary, you can disable this feature by unchecking Caption within the properties of your SQL Query View object. If I select a row, you'll notice the data is transferred from our result object to our output registers. Let's modify our data and then trigger our create command. Now at first glance it may appear as though nothing has happened, but remember we've configured our query to discard the result, and our statement will only add a new row. It will not perform a subsequent read command. So let's do this now. And we can see that our new row has been added to our database. Let's close our simulation, and I'd like to demonstrate some slightly more advanced functions within our SQL Query object. I'm going to create a new command. The command that I'm going to create will allow us to search our database for rows with a specific name. Although I haven't done this during my demonstration, I'd like to mention that it is always helpful to test your queries within your SQL Workbench prior to using it within your project. As our query object will not display syntax errors, its purpose is to send your query to the database where it is then processed. To create this query, we'll use another select statement. I'll type select asterisk from my table where, and now let's add an argument. Our argument will pass string data into our query, and it will be addressed to LW77. Now back within our query, I'm going to type name equals, and we'll use our syntax for our argument, apostrophe, $, and in curly brackets we'll type 1, and then close this with a second apostrophe and a semicolon. So what we're doing is defining a condition or constraint which establishes specific criteria that our result must return. Let's take note of our command value and then click OK. And before we exit, I want to create one last query. I'm going to name our command table : mytable/copy. And in this command, I'm actually going to call a procedure that I've already configured within my SQL database. To do this, I'll type call, and our stored procedure's name is copy. Now let's define some arguments. The purpose of this procedure is to copy data within the current selected row and insert it as a new row. So we'll need to define the output registers from our read command as arguments. These registers were LW71 and LW72, with LW72 being a 5-word string. Now within my Query tab, I'm going to place in a set of closed parentheses the syntax for my arguments, and we'll end our statement with a semicolon. And then I'll click OK, add some objects for each command, and then run an offline simulation. To start, I'll select a row, and I'll use the copy procedure to duplicate some data. And now let's search through our data by using our search command. And this was a brief introduction to SQL Query in advanced mode within EasyBuilder Pro. If you found this tutorial helpful and would like to see more, head on over to our channel to check out the latest technical tutorials. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.